Welcome to the lecture Distributed Systems. Today we are going to discuss interprocess communications in distributed systems. Interprocess communication in the internet provides both datagram and stream communication. The application program interface to transmission control protocol provides the abstraction of two-way stream between pairs of processes. The information communicated consists of a stream of data items with no message boundaries. Streams provide a building block for producer-consumer communication. A producer and a consumer form a pair of processes in which the role of the first is to produce data items and the role of the second is to consume them. The data items sent by the producer to the consumer are queued on arrival at the receiving host until the consumer is ready to receive them. The consumer must wait when no data items are available. The producer must wait if the storage used to hold the queued data items is exhausted. The characteristics of interprocess communication are message passing between a pair of processes can be supported by two message communication operations. They are send and receive, defined in terms of destination and messages. To communicate, one process sends a message to a destination and another process at the destination receives the message. This activity involves the communication of data from the sending process to the receiving process and may involve the synchronization of the two processes. A queue is associated with each message destination. Sending processes cause messages to be added to remote queues and receiving process remove messages from local queues. Communication between the sending and receiving processes may be either synchronous or asynchronous. In the synchronous form of communication, the sending and receiving processes synchronize at every message. In this case, both send and receive are blocking operations. Whenever a send is issued, the sending process or thread is blocked until the corresponding receive is issued. Whenever a receive is issued by a process or thread, it blocks until it arrives. In the asynchronous form of communication, the use of send operation is non-blocking. In that, the sending process is allowed to proceed as soon as the message has been copied to a local buffer and the transmission of the message proceeds in parallel with the sending process. The receive operation can have blocking and non-blocking variants. In the non-blocking variant, the receiving process proceeds with its program after issuing a receive operation, which provides a buffer to be filled in the background. But it must separately receive notification that its buffer has been filled by polling or interrupt. If the client uses a fixed internet address to refer to a service, then that service must always run on the same computer for its address to remain valid. This can be avoided by using the following approach to provide location transparency. Client programs refer to services by name and use a name server or binder to translate their names into server locations at runtime. This allows services to be relocated but not to migrate, that is, to be moved while the system is running. Reliability. A point-to-point message service can be described as reliable if messages are delivered despite a reasonable number of packets being dropped. In contrast, a point-to-point message service can be described as unreliable and it is not guaranteed to be delivered in the face of even a single packet drop or integrity of the messages must be lost. Ordering. Some applications require that messages to be delivered in the sender order, that is, the order in which they were transmitted by the sender. The delivery of messages out of sender order is regarded as a failure by such applications. For example, video. Sockets. Both forms of communication, that is, user datagram protocol and transmission control protocol, use the socket abstraction, which provides an endpoint for communication between processes. Sockets originate from BSD Unix but are also present in most other versions of Unix, including Linux as well as Windows and the Macintosh operating systems. Interprocess communication consists of transmitting a message between a socket in one process and receiving the message by a socket in another process. You can see here the INET address or internet address of sending process and the receiving process internet address. You can also see here port, and also different ports are available in client machine as well as in the server machine. What are the APIs required for internet addresses in Java programming language? As the IP packets underlying UDP and TCP are sent to internet addresses, Java provides a class called INET address that represents internet addresses. Users of this class refer to computers by domain name system or host names. For example, instances of INET address that contain internet addresses can be created by calling a static method of INET addresses, giving a domain name service hostname as the argument. This method uses the domain name service to get the corresponding internet addresses. For example, to get an object representing the internet address of the host whose domain name server name is vnrvjt.ac.in. So how we can write it as in the programming language? INET address, a computer is equal to INET address get by name vnrvjt.ac.in. So a computer is an object and it will receive the internet address of or IP address of vnrvjt.ac.in. Generally, if the host is not found, this method can throw an unknown host exception. A datagram sent by UDP is transmitted from a sending process to a receiving process without acknowledgement or retries. If a failure occurs, the message may not arrive. A datagram is transmitted between processes when one process sends it and another receives it. To send or receive messages, a process must create a socket bound to an INET address or internet address of the local host and a local port. A server will bind its socket to a server port, one that it makes known to clients so that they can send messages to it. A client binds its socket to any free local port. The receive method will return the internet address and the port of the sender in addition to the message, allowing the recipient to send a reply. If the message is too big for the array, it is truncated on arrival. The underlying IP protocol allows packet lengths of packet lengths of up to 2 power 16 bytes, which includes the headers as well as the message. However, most environments impose a size restriction of 8 kilobytes. Any application requiring messages larger than the maximum must fragment them into chunks of that size. Generally, an application, for example DNS, will decide on a size that is not excessively large but it is adequate for its intended use. Blocking. Sockets normally provide a non-blocking sends and blocking receives for datagram communication. Receives. The receive method does not specify an origin, but it can receive a message from any client or from any system. Failure model for UDP datagrams. A reliable communication is defined in terms of two properties, that is integrity and validity. The integrity property requires that a message should not be corrupted or duplicated. The use of a checksum ensures that there is a negligible probability that any message received is corrupted. UDP datagrams suffer from the following failures. One is a omission failure. Messages may be dropped occasionally, either because of a checksum error or because no buffer space is available at the source or destination. Ordering. Messages can sometimes be delivered out of sender order. We will discuss remaining points in the next class. Thank you. Thank you very much.